Hi guys, before starting the problems, let me take just maximum couple of minutes of yours. First of all, yesterday evening at around 6 o'clock, I came to live, and I took 1 hour 7 minutes plus yesterday, and I was able to solve 11 questions. You have to listen to this, okay? And yesterday only, immediately after live, I went to recording of the same questions plus extra questions, and within 49 minutes, I was able to record 17 questions. In essence, 11 plus 6 questions I was able to do in 49 minutes with a detailed explanation. You can compare live also and you can compare recording also. Meaning that with recording, because I prefer always recording. With recording, you can complete like lecture, like kind of condensed information will be condensed such that in a short period of time, videos can be completed on them. And second thing is there are two types of classes. Kind of analysis class will be there. Analysis class will be there, and also problems class will be there. Okay. In analysis class, one problem is there, and in problems class, one problem is there with recording. I personally feel I don't want to bias anyone. Means I will tell my like whatever I feel personally, I'll share that. And my version, let me tell you. If I think of analysis, if the class is about to be started at 6 p.m., 6 p.m. How many of you would attend? Like you can think of any YouTube channel live or any kind of any platform live. If class is scheduled at 6, how many of you are starting the class at, are sitting in front of the laptop or PC or your mobile, in front of your mobile or system? By 6 o'clock, how many of you are starting the class? 99% of people are not watching, are not starting the class. For example, if you start your class at 6:30 or 6:15 after the class, then problem is without understanding that 15 minutes or half an hour of class, you cannot continue. But at the same time, already in the middle of the class, you are going to join. It would be a problem. And in analysis class also and in problems class also, time requirement for live is going to be more. Why? Because most of the times, students are in offline classes. If you see in offline classes, eye-to-eye contact will be there, and group motivation levels will be always high because a group of students will be there. Obviously, their subconscious mind will completely focus on the class only because it cannot be repeated. Offline classes like coaching center classes. So then productivity will be more because subconscious mind will be completely focusing on the class. But here, problem here is once live is over, anyway we can see recording. But because of lack of control, eye-to-eye contact, our complete trained mind, because in the offline classes, we used to maintain that focus of the students on the board. But in live classes, eye-to-eye contact will not be there. So because of that, they will ask obviously irrelated some information. For example, if we take networks theorems, they would ask about resonance. If we discuss resonance, they would ask about control systems because their energy levels means students are very energetic, youth and energetic fellows. So their mindset will wander because of lack of kind of control, eye-to-eye contact, because of lack of that. Now, if you think of problems also, for example, for one of the problem, if I have taken 2 minutes of time, 2 minutes of time for one of the problem, then if you are stronger than me, you can take less than 2 minutes. Or if you are weaker than me, the kind of, at that point, if you don't get the idea of that, you may take greater than 2 minutes. In both the cases, it is going to be time waste. Because, for example, if you are able to solve the question in 30 seconds, remaining 1.5 minutes you have to wait. Yesterday, Surajit Mitra, like one of our paid students, he was able to answer the questions, but I had to wait. His time is getting wasted. For example, I have taken 2 minutes, but you would take 5 minutes. You would take 5 minutes. Then you are not going to train your mind. For example, if it is recorded version, like you can stop the video, you can take down the problem, and you can train your mind. You may get answer, you may not get answer, it doesn't matter. Ultimately, training matters. Because at starting, your mind may not give you any idea. But after some time, it will start giving. Maybe for that problem, it may not give any idea, but next problem it may give, next problem it may give. In that way, means we'll be able to train the mind. Okay, but in this case, training of the mind will not happen, because if you would have worked hard for 5 minutes, you would have got the answer. Because of that, in the subconscious mind, you would have developed confidence, right? But it means you are not given 5 minutes of time, because in 2 minutes only problem is going to be solved in life. What does it mean? What does it mean? Your mind is not getting trained. Your mind is just getting the information. Okay, this problem has to be solved in this way, this problem has to be solved in this way. In that way, if you try to memorize many types of problems and many types of ways, how can you get creative idea in the examination? Okay, but anyway, let me start now. Of course, I already recorded. Let us start with problems of last year. Yesterday's 11 questions will be there, and after that 6 more questions will be there. Let us see. Okay. Hi guys. In this session, let us try to solve some problems in theorems. But before going ahead, one important thing. Always you should keep this particular point in mind while solving at least 70% of the network theory. In between mesh and model, which has to be used. Okay, because multiple times many students maybe they might be acquainted with mesh analysis, and they will try to use mesh only. They don't think about model. At BTech level, it can be fine. But for GATE level or ESE level, we should get the solution as fast as possible, in shortest time possible. Meaning that in between mesh and model, we should identify which method should be proper to use, such that in a shortest way we are going to get the answer. Kind of in mesh analysis, how many equations we are going to form, and in model analysis, how many equations we are going to form, and depending upon the number of equations variance, we have to choose the method. Okay, directly, as we are acquainted with mesh analysis, we are not supposed to use mesh analysis. And in this, I will tell you some mistakes normally people do also. Okay, now let us take this. For the circuit shown in figure, the Thevenin voltage and resistance looking into X, Y, R. They are asking voltage also, and they are asking equivalent resistance also. And of course, AC problems are also there, we are going to solve. Now, voltage also, resistance also. Thevenin's equivalent voltage also we should know, and Thevenin's equivalent resistance also we should know. And we are having dependent sources there, independent sources also there. We are having both. What does it mean? We have to find out. Both VOC also we have to find out, and short circuit current also we have to find out. And then as per that, RTH has to be formed with the VOC by ISC. Okay. Here, let me tell you one mistake like normally people do. Means some people at least. They feel that, for example, in VOC, okay, in open circuit voltage condition, circuit configuration is different. Short circuit condition, circuit configuration is different. So some people do in open circuit condition, they will calculate something, and those particular values they will try to use in short circuit condition. No. Okay, open circuit condition we have to fresh use KCL KVL mesh model. Short circuit condition we have to again fresh use from basics KCL KVL or mesh model in order to find out the required output. Now, first of all, let us think of open circuit. Okay, in open circuit condition, which method is better to use? That has to be found. Okay, so open circuit voltage, let me call it as V. Open circuit condition. Now, let us think of nodal and mesh. If you see how many nodes are there first node, second node, third node. 3 nodes are there, out of which 1 node will go as a reference node. 1 node will go as a reference node. So remaining 2 nodes are there. And that too, if you observe this particular voltage source, it is directly connected with respect to the reference. Meaning that what is this particular voltage now is going to be 2I directly. You need not apply specifically any KCL there. Okay, because this particular nodal means in nodal analysis, voltage we are supposed to get that particular voltage already I know, 2I volts. Okay, so this particular node we need not apply any kind of KCL. Here only we have to apply. So with nodal analysis we are going to form only one equation. Now let us think of mesh. Again, we have to find open circuit voltage only, but in order to find open circuit voltage, if you try to find open circuit voltage by applying KVL or mesh analysis, how many meshes are there? 1, 2, 3. In that, if I name it as I1, I2, I3, of course, one relation will come, one supermesh will come, forget about it. One relation is going to be I3 minus I2 equal to 2. I3 minus I2 equal to 2 amperes. One relation. And remaining 2 are going to be direct KVL equations. In the sense, 3 meshes, 3 equations will come. In that, 2 equations has to be formed by KVL and 1 equation has to be formed by relation. So what has to be done? Nodal would be better for this. because only one model equation we are going to get. Okay, and the next thing is, okay, so this is going to be V, meaning that this is going to be V with respect to this, and this particular nodal voltage is 2I. Okay, and one more thing here is, means this is 2I. Where is the controlling variable? Controlling variable is current flowing through this. This is I. Okay, now can I convert this particular voltage source, equivalent voltage source, into equivalent current source? Yes, we can do that. Right? Once you convert, keep this particular point in mind. Okay, 2I, 1 ohm. Definitely you can convert this into equivalent current source. Then that 1 ohm will come here. This 1 ohm and this 1 ohm, can I mix? Can I combine into equivalent resistance? No. Okay, let me tell you here. See here, if I convert that dependent voltage source into dependent current source, it is going to be 2I by 1. 2I by 1 is going to be 2I amperes. And then this 1 ohm will come in parallel. 1 ohm will come in parallel. And here, anyway, this 1 ohm is already there. So, this is going to be 1 ohm. Now, can I combine these two into equivalent resistance as 0.5 ohm? No. Why? Because controlling variable is going to disappear. For example, this is controlling variable, right? If I combine these two, where is I? I is going to disappear. If I is disappeared, how to calculate 2I? No. Okay? We are not supposed to do that. Anyway, let us keep it as it is, and because only one nodal equation, right? So V minus 2I, leaving current. Normally, I prefer leaving currents as positive, depending upon duality and all, and anyway. V minus 2I divided by 1 is going to be leaving current here. V by 1 is going to be leaving current here. Minus 2 is leaving current here because 2 amperes is entering. And V by 2 is going to be leaving current here. Okay, let us write V minus 2I by 1 plus V by 1 minus 2 are equal to 2. V by 2 plus V by 2 is going to be leaving current. Simple. Now, what is I here? What is I here? Okay, so this is going to be I, right? What is I? V by 1 is going to be I, is nothing but V. Now, equation is simple. V minus 2V is going to minus V plus V by 2 is going to be 2. So, V is going to be 4 volts. So, open circuit voltage VOC or V Thevenin equal to 2 into 2, 4 volts. Problem solved. Okay, so this is 4 volts. Now, let us erase this, because this particular content we are not supposed to use it again in short circuit, because circuit configuration is going to be changed. Now, let us think of short circuit. ISC has to be formed. Here, in order to calculate ISC, of course, no need to use any separate things and all, because 2 ohms across 0 ohms resistance, short circuit. So, how much current would flow through this? 0 amperes. Across this 1 ohm. Okay, how much current would flow through this? Maximum means total current will go through short circuit only. Across short circuit, some resistance is there. This will be 0 amperes. If this current is 0 amperes, controlling variable is 0 amperes. So, controlled source value 2I, 2 into 0 is going to be 0 volts. Okay, then this one, once this is short, because voltage source, no, 0 volts in the short circuit. So, this one, these two, connected in parallel with short circuit. So, total 2 amperes current will flow through this only, short circuit only. So, ISC is going to be 2 amperes. Right? Now, what is RTH? RTH is going to be for 4 by 2 is going to be 2 volts. 4 volts, 2 volts. Okay? Now, let us think of this. In the circuit shown, the voltage Vx in volts. This is directly like, it is not related to theorems, but anyway, measure nodal is important. Okay, so this is, hope you are able to see. Yeah, so this is 0.5 Vx actually. This is 0.5 Vx. This is going to be current source in this direction, and this is Vx. This is Vx. Okay, now let me reduce this. If you want, like, you can stop the video and do that. Okay, now next thing is, see here. This is better. Okay, now Vx has to be formed. Vx has to be formed. Now, if you see again, because unnecessary things we are not supposed to do. This current source is there, no? This current source is in parallel with the resistance. Now, can I convert these two into equivalent voltage source? No. Why? Because if you convert, for example, one current source is there like this, okay, and this is resistance of 5 ohms, and this is current source of 1 ampere. And here, for example, if it is open circuit, if it is means external circuit that is about to be connected is open circuit, under that condition, how much will be the voltage across 5 ohms? Is going to be 1 into 5 volts. Okay, these are the things which are actually very important, because in that pressure will be there in the exam, because the pressure will try to apply combinedly everything. Okay, anyway, if I convert this into voltage source, okay, if I convert this into equivalent voltage source, this is 5 ohms resistance as usual, and 1 into 5 volts. And again, if the external circuit is open circuit, okay, here also external circuit is open circuit. When external circuit is open circuit, how much is the voltage across 5 ohms is 5 volts. When external circuit is open circuit, how much is the voltage across 5 ohms? 0 volts. Okay, so from here to here, voltage across 5 ohms is going to be changed. In the same conditions, sectional conditions are same. So what is important here? So the moment if you have any kind of controlling variable here, you are not supposed to transform the sources. Okay. Now see here, this particular current source and this particular resistance we are not supposed to transform, because this is the controlling variable. With this controlling variable, 0.5 Vx is there, one current source. We are not supposed to transform. Anyway, see here, which method is better? Okay, how many nodes are there? This is reference node, first node, second node. 2 nodes are there. And in the two nodes also, this particular voltage source is connected with respect to reference, meaning that this voltage is directly 0.25 Vx. Okay, even though it is not visible, like already you stopped the video, right, to take down the problem. Now this particular node I need not bother. So only extra node is only this. This particular node only one equation has to be formed. Now if you think of mesh analysis, okay, if you see mesh analysis, mesh, how many equations came? 4. Just chill, relax. Okay, 4 equations came. But out of 4 equations, if I think of this as I1, I need not apply KVL here, because I1 is nothing but 5 amperes only, direct current source. So I1 equal to 5 amperes. This is one relation. And if I think of this as I2, this as I3, this as I4. And what is I4? I4 is nothing but 0.5 Vx. I4 is nothing but 0.5 Vx. Second relation. 2 relations. But remaining 2 equations has to be formed, no? Remaining 2 equations has to be formed. So 2 equations and 2 relations in case of mesh, and only 1 equation and 1 relation in case of nodal. So nodal would be better here. Let us apply nodal. Okay. So if I think of nodal, this particular voltage is going to be 0.25 Vx, and this is reference. And this particular node voltage is Vx. Okay. Now let us apply KCL. Only 1 equation, only here. If I apply equation here, current leaving in this direction is going to be Vx. Current leaving in this direction is going to be Vx minus 0.25 Vx divided by 10. Current leaving in this direction, and in this direction Vx by 20 plus Vx by 20. Current leaving in this direction, and the current leaving in this direction is going to be plus 0.5 Vx equal to current entering is 5. So this is 5. We have to solve this. Okay. So if I try to solve this, it is going to be 0.75 by 10 plus 20 inverse plus 0.5, 5 divided by plus 8. So here Vx is going to be 8 volts. Vx is going to be 8 volts. Right? So try to focus mainly on which method to use. That is more important. In this problem, in the circuit shown, what are the values of RL that maximizes power delivered to RL? Power delivered to RL should be maximum. So what has to be done? We are supposed to convert this into Thevenin's equivalent. Okay, if I can convert this into Thevenin's equivalent voltage, Thevenin's equivalent resistance, okay, and when load connected, when load connected, if it is variable, and then when this RL value equal to RTH value, maximum power will be transformed to here. And fortunately, in the question, they asked only resistance. They did not ask kind of Thevenin's equivalent voltage source or power transform, maximum power transformer. They did not ask. So we need to calculate only RTH. We are going to have three cases in Thevenin's. Okay. First case is going to be when you have only independent sources. When we have only independent sources, directly VOC we are going to calculate. And RTH directly we are going to calculate by killing sources. How to kill a voltage source, short circuit. How to deactivate a current source, by open circuit. Now, second category is going to be when you have both independent source and dependent source. When you have independent and dependent, then what you are supposed to do? Open circuit voltage you are supposed to calculate, and short circuit current also you are supposed to calculate, and RTH is going to be VOC by ISC. RTH or GATE. Of course, easy problems also we are about to solve. Okay. Now, third case, when you have only dependent sources. When you have only dependent sources, then VOC will become 0, even if you cannot calculate. ISC also will become 0. But in that case, how to calculate RTH? That particular network we are going to consider only with dependent sources, and to that we are going to connect some external supply, either voltage source or current source. And then, means for example, if I connect one voltage source here, Vs, known value, then we are going to find out Is, such that Vs by Is is going to be RTH. VOC, ISC or VTH, I Norton will become 0. And so RTH is going to be Vs by Is. Or you can connect current source and you can find voltage across that particular current source also will be fine. Now coming to this question, it is having both independent source and dependent sources. Independent source and dependent sources. But still, they asked in the question that only load resistance, how much should be the load resistance such that maximum power should be transformed. Meaning that RTH would be sufficient, VTH need not be found. If VTH need not be found, what has to be done? Means directly we know we can kill the independent source or not. Dependent sources cannot be killed, but independent sources can be killed. So what we can do is, rather than having VOC and ISC calculation, because for example in the same question, if they are, previously also we solved one question, right? If they ask you VTH also, if they ask you RTH also, in that condition VOC has to be calculated, ISC has to be calculated, and RTH has to be found. But here VTH they did not ask, only RTH. The moment RTH is they asked, because in order to calculate VOC, one separate circuit configuration. In order to calculate ISC, one separate circuit configuration. KCL KVL mesh model here, KCL KVL mesh model here, 2 times. Why to apply? Rather than that, our third case is there, no here. Okay, just try to maintain only dependent sources only, and kill independent sources. And external activation if you can do with voltage source or current source, directly RTH can be found. So what I am trying to do is, I am going to kill this because it is independent voltage. Can I kill this? No. Okay. Now, if I kill this, this is better. If I kill this, just a minute. Yeah. If I kill that 100 volt source, circuit will become like this. Okay. Circuit will become 4 ohm, 4 ohm, 4 ohm plus minus Vx. Where is Vx? Vx is here. This is 4 ohm, this is 4 ohm, this is 4 ohm. 100 volts is short circuit. And here you have to connect with some external source. Which is better to connect, either current source or voltage source? That also we have to decide. Okay, because anything can be used. Now, in this network, which is better to use? What is a current source or voltage source? Obviously voltage source, because if I use voltage source, see here, means this particular controlling variable is there, no controlled source. If you can make that controlled source kind of independent source, calculation will be easy. If I connect, for example, here 8 volts voltage source, just like 1 volt also can be connected, 8 volts also can be connected, it's my wish, because linear. If I connect 8 volts, 8 divided by 8, so here 1 ampere current will go. 1 into 4, here 4 volts will be there. and Vx equal to 4 volts. So here you are going to get 4 volts. Okay, so that particular Vx controlling variable of the control source became constant now. Calculations would be easy. Anyway, we have to find out the current flowing through this. Yes. Now this particular current is nothing but this current plus this current. 8 volts. So here up to here 8 volts is there. 8 minus 4 by 4 is going to be 1 ampere. 1 plus 1 is going to be 2 ampere. 8 by 2 voltage source and current flowing through the voltage source. 8 by 2 RTH is going to be 4 volts. So how much should be our load resistance such that my load resistance will get maximum power transfer is going to be how much? 4 volts. So this is going to be 4 volts. Okay. Now let us take this. I hope this is big enough. Means you can stop the video and you can go through. See here in this question they specified that plus minus voltage source is there, and here plus minus voltage source is there, and here resistance value is going to be 1 ohm. And in the question they specified that if this particular V1 is only excited and V2 is killed, short circuit, then power absorbed is 1 watt. And when second source is only acting alone and the first source is short circuited, under that conditions P2 they have got 4 watt. 4 watt. Now if both the sources are acting simultaneously, how much should be the power absorbed by resistance? Now can I apply linearity to the power? No. We can apply linearity between voltage and current only, not for power. So means directly 1 plus 4 5 or 4 minus 1 or 3 should not be there. First of all, we have to consider it as a resistance. How much is the resistance value of 1 ohm? Now when this is short circuited, and when this is only acting, then plus is here, minus is here. So somehow I1 current should flow in this direction. Then how much is the power absorbed is going to be 1 watt. And like the moment power absorbed, I square R already we know, right? So I1 square R equal to 1 watt. Resistance equal to already 1 ohm. So I1 is going to be 1 ampere. Now let us see here. When this particular source is only acting alone and this particular source is killed, under that condition current. Okay, see here, this is plus, this is minus. So current should go in this direction. Okay, top to bottom. So in this direction, current is going to be I2. And how much is I2 square R2? When second source is only acting alone and first source is killed. Under that condition, 4 watt. And how much is resistance? 1 ohm already. So how much will be I2? Is going to be 2 amperes. So is going to be 2 amperes, top to bottom. And bottom to top it is going to be 1 ampere. Now I1 plus I2 is going to be net resultant because superposition can be applied to voltage and currents. So net resultant current is going to be 1 ampere. When both the sources are acting simultaneously, so I square into R of resistance of 1 ohm is going to be 1 watt. Okay. Now this is also a very beautiful question. See here, assuming both the voltage sources are in phase, of course AC they have given just to specify minus J1 and all that set. Okay, the value of resistance means this and this are in line with each other. Okay, phase displacement between this particular source and this particular source is 0. Now the value of R such that maximum power is transformed from circuit A to circuit B. Maximum power is transformed from circuit A to circuit B. Forget about circuit B for time being. What is circuit A? Circuit A is having 10 volts, 2 volts, right? This is circuit A. When circuit A will be able to transform maximum power, when this is connected with a resistance of 2 ohms, such that load resistance equal to source resistance, maximum power will be transformed. Under that conditions, how much will be current flowing through 2 ohm? 10 divided by 4 is going to be 2.5 amperes. How much will be this particular potential? Is going to be 10 by 2 is going to be 5 volt. Problem solved. See here after 2 ohm, voltage across this should be 5 volt, and current flowing through 2 ohm is going to be 2.5 amperes. Now apply Ohm's law enough, because voltage here is 5 volt and voltage here is 3 volt. So how much current should flow in this direction is going to be 5 minus 3, 2 ohm divided by 2.5 amperes, 2 volt. Okay, so 5 minus 3, current flowing through that is going to be 2.5, should be equal to 5 minus 3 by R. 5 minus 3 by R. Then R is going to be 2 by 2.5, 0.8 volts. Fine. Now let us take one more. This is a funny question. The value of resistance are connected across terminals A and B, which will absorb maximum power AC. Hope it is visible. Okay. Now, see here. Across A and B, R is connected, and in R we have to get maximum power. And of course, they did not mention whether it is a voltage source or current source except the symbol. Means we have to assume it is a voltage source, because most of the times voltage source and R only will be there. So if I think of this as voltage source, ideal voltage source. Now, in order to calculate RTH only, how to calculate RTH? Already we have seen first case. When you have only independent sources can be killed. And then, means across these two, by looking into the system, we have to calculate resistance, RTH. They are asking only RTH. Now, long back, I told you one thing. Then, whenever you have long short circuit paths, give node numbers. Okay, and this is A, this is B, long short circuit. So let us think of this as X. This is X. Now, this 3K is connected between A and X. This 6K also connected between A and X. If I think of this as A and X, A and X. Okay, so this is X. A and X 3K, and A and X 6K. And from X, X to B 4K. See here, X to B 4K, X to B 4K. So X to B 4K, X to B 4K. So this is going to be B. That's it, right? So equivalent resistance will be 3 into 6 by 3, R1 R2 by R2 plus R2. 3 plus 6, 9 plus 4K, 2K is going to be 4K. Right? So answer is going to be, is not there, but answer will be 4K. Okay? Take this. Thevenin's equivalent voltage VTH appearing between terminals A and B of the network shown in figure given by this. See, one thing I'll tell you here. The moment AC analysis, somehow people will be scared, especially EC guys. That's why in EC paper they have very little paper. We should have done very easily. They are asking open circuit voltage only, VTH only they are asking. VTH only they are asking. Then it is actually very easy for us, right? Because if anything is connected across ideal voltage source, for example, what is the potential difference across this 100 volts? What is the potential difference across this 100 volts? What is the potential difference across this 100 volts? So, remove it. In finding voltages, anything connected in parallel with the ideal voltage source can be neglected. Now, forget about it. Now, this is going to be, how much will be VTH here? Simple. VTH is going to be 100 at an angle 0 divided by current flowing through this is how much? Divided by 3 plus J4 current into J4 will be the answer. Okay, so this is going to be J400 at an angle 0. Okay, J400 divided by 3 plus J4 into 3 minus J4 by 3 minus J4. Right? So this is going to be J400 into 3 minus J4 divided by 9 plus 16, 25. Okay? So 25, 16. J16 into 3 minus J4. J16 into 3 minus J4. This is the answer. Okay? Now, at starting it may seem kind of lengthy question. Okay? Hope you are able to see. but it is not. It is actually simple question only. See, the circuit shown below, if the source voltage Vs is 100 at an angle 53.13. This is 100 at an angle 53.13 degrees. And this is 3 plus J4, and this is J40 I2 voltage source, and I2 is here. Here control source is here, controlling variable is here. And this is 10 VL1 voltage across this. Voltage across this is this. VL1 is the voltage across inductor, and into 10 is going to be voltage of the, means it is kind of voltage controlled voltage source, it is kind of current controlled voltage source. Simple, just like. Now, then the Thevenin's equivalent voltage in volts as seen by the load resistance RL. Okay, this is RL. As seen by the load resistance, they are asking for the Thevenin's equivalent voltage only. How to calculate Thevenin's equivalent voltage? We will see open circuit voltage. So let us open circuit this. If open circuit this, how much is I2? I2 is going to be 0. Once open circuit. Once I2 is 0, J40 into I2 is going to be 0. Voltage source 0. 0 volts voltage source is nothing but short circuit, we know. So this is going to be short circuit. Now calculate I1 into 10 is going to be the answer. Open circuit source. So this is VTH equal to I1 10. Sorry, just a minute. So this is 10 VL1. 10 VL1. 10 VL1. VL1 equal to voltage across this. Okay. So if I calculate 10 into what is VL1 is nothing but I1 into J40. I1 into J4. What is I1 is nothing but 100 at an angle 53.13. 10 into 100 at an angle 53.13 divided by the impedance. 100 at an angle 53.13 divided by 3 plus J4 into J4. Okay, simple. Say this is short circuited, Vs divided by this impedance I1 into J4 VL1 into 10 is going to be the answer. Okay, so this is going to be 10 into 100 at an angle 53.13 divided by 3 plus J4, 5 at an angle 53.13 into J4. This is going to be 2 and 800. So 800 J. Okay, 800 at an angle 90 degrees. Okay, now let us take one more problem. See here, this is reciprocity theorem. Use data of the means they have given some data here. By using that data, we have to find out in this condition. Okay, see here, they have given 10 volts. This is 10 volts. For this 10 volts, I got current in this direction of 2 amperes. If I do into 2, it will be into 2. So if it is 20 volts, it is going to be 4 amperes. Now, by using reciprocity theorem, if I connect here 20 volts, current flowing in this direction would be 4 amperes. Okay. Now let us see. If I keep 20 volts in reverse direction, because plus is here, minus is here, in reverse direction 20, and the current is in the same direction. Okay. See here, if I have voltage in this polarities of 20 volts, current in this direction is going to be 4 amperes. Once polarities are reversed, plus here, minus here of 20 volts, current direction also should be reversed upwards of 4 amperes. But in downward they asked, so it is going to be minus 4 amperes. Okay. Now let us take this question. In the circuit shown below, the Norton equivalent current in amperes with respect to the terminals P and Q. Norton equivalent they asked. It's simple. Okay. Norton equivalent across PQ they asked. Now, see here, the moment it is short circuited, across J50, will there be any current flowing through this? No. Under short circuit condition, Norton's current is nothing but short circuit current only, right? So you have to find out current flowing through this. See here, individually it is becoming like this. And this is 25 ohm. and this is 16 at an angle 0, and this is J30 ohm, and this is 15 ohm, and this is short circuit current. Current division rule, total current, and this impedance are connected in parallel. So I'm trying to calculate current flowing through this impedance. Is how much? Total current into other resistance by total resistance. Total current into current flowing through this I want. So other resistance divided by total resistance or impedance, whatever it may be. 25 plus 15 plus J 30 volts. Right? Now let me use calculator. 16 into 25 divided by 40 plus 30 I. 6.4 minus J4.8. 6.4 minus J4.8. Okay. Now let us see this question. For the circuit shown in figure, Thevenin's voltage and Thevenin's equivalent resistance at terminals A and B. See, both they asked. Thevenin's equivalent voltage also they asked, and Thevenin's equivalent current also. Sorry, Thevenin's equivalent resistance also they asked. Meaning that open circuit voltage has to be calculated, short circuit current also has to be calculated because dependent source is there, independent source is there. Okay. Now let us see. Now see here, across A and B, open circuit voltage circuit configuration is different, short circuit current circuit configuration is different. Okay, let me think of open circuit voltage. Open circuit voltage, let me keep it a bit bigger only. Okay, that's fine. So let me try to calculate open circuit voltage. In calculating open circuit voltage, again, mesh or nodal. See here, if you think of nodal analysis, how many nodes are there? 1, 2, 3, 4. 4 nodes are there. Out of 4 nodes, 1 node will go as a reference node. 1 node will go as a reference node. So in remaining 3, 1 node is connected directly with the reference node to non-reference node. 1 voltage source is there. So directly this particular voltage is going to be 0.5 I1. We need not apply KCL there. And here also 1 voltage source is connected directly with respect to reference node. So this node voltage is 10 volts. Now you are supposed to calculate, or you are supposed to apply only one model equation. Okay, directly KCL you are supposed to apply only once. Now if you think of mesh, okay, so let us think of mesh. If I think of mesh, I1, I2, 2 mesh equations will come. Now in two mesh equations, only means first one, if you see for example this is I1, how much is I1 value? Is 1 ampere directly. 1 ampere directly. So one mesh equation will come or one nodal equation will come. If you think of nodal also, one equation only will come. If you think of mesh also, one equation only will come. Right? Because directly I1 equal to 1 ampere and only one mesh will come. If you think of nodal, only at this particular node only one equation has to be applied. So mesh is also same, nodal is also same. Now which method has to be applied? What is your intention? Your intention is voltage has to be calculated, and in nodal analysis directly you will get voltage. If you think of mesh analysis, by using mesh analysis you are going to calculate current, and as per that you are supposed to calculate voltage, meaning that one more step has to be further taken. Okay, directly let me use nodal only. Why? Because my ultimate target is open circuit voltage. Now let me think of this as open circuit voltage V with respect to reference. Here I need not apply. Here I need not apply because voltage sources are connected with respect to reference node. Now, in applying KCL here, directly entry current is 1 ampere and leaving current through this is V by 5. Leaving current through this is plus V minus 10 by 5. V by 5 plus V minus 10 by 5, leaving current equal to entering current. What is the significance of this particular dependent source in this network? There is no significance. Why? When anything is connected in series with the current source, in applying KCL, that is insignificant. Okay? Means, for example, if I try to apply KCL here, how much will be the current? Anyway, leaving current is 1, meaning that entering current is 1, that's it. If anything is connected in series with a ideal current source, can be neglected in applying KCL. If anything is connected in parallel with ideal voltage source, in applying KVL, those can be neglected. Because KVL voltage should be known. When anything is connected in parallel, voltage is going to be same. And KCL, currents. And if anything is connected in series to the current source, currents is going to be known, so we need not bother about it. Ultimately, though they have given dependent voltage source, significance is not there. Now, anyway, V by 5 plus V by 5 equal to 3. 2 plus 1, 3. So 2V by 5 equal to 3. So that means that V equal to 2 equal to 7.5 volts. 7.5 volts. Thank God. 7.5, only one is there. Anyway, let us calculate ISC also and try to find out RTH also. Okay. So the moment you want to calculate ISC, some complete circuit configuration has to be changed. We are not supposed to use any values whichever we got in previous open circuit conditions. Now let us think of short circuit conditions. Let me use same network. Short circuit. Okay. In short circuit, 100 by 5. 100 by 5, 2 amperes will go in this direction. 2 amperes. Once it is short circuited, across short circuit, some resistance is there, no current will flow. So 1 ampere will go through this. So how much is the short circuit current is going to be 3 ampere. So ISC is going to be 3 amperes. If ISC is 3 amperes, open circuit voltage is 7.5. How much will be RTH? RTH is going to be 7.5 by 3 is going to be 2.5 ohms. Okay. Let us see this question. In the circuit shown, Norton equivalent resistance in ohms across terminals A and B is Norton's equivalent resistance. Only resistance they asked. Why? Because only dependent sources. We don't have any independent sources here. Meaning that external supply we are supposed to supply. The external source we are supposed to connect. Either can be voltage source or current source. Which source would be better? Let us see now. See here, 4I, 2 ohm, 2 ohm, 4 ohm. And here we are supposed to connect external supply. Because the moment you have only dependent sources, open circuit voltage will be 0, short circuit current will be 0, but Thevenin's equivalent resistance will be there. Now, across AB, we are supposed to connect some source, known source, which is better to apply. Voltage source or current source. If I apply current source, I don't know this current, meaning that I don't know this at starting. For example, if I connect voltage source of 4 volts, 4 by 4, I is going to be 1 ampere, meaning that 4 into I is going to be 4 volts directly. It's a kind of that dependency is gone. The moment you connect a voltage source, this is going to be constant, this is going to be constant, so we need not bother much. Okay. Now, again, if you see, ultimately current flowing through this has to be found such that 4 divided by ISC is going to be the resistance, Thevenin's equivalent. Now, how much is the current flowing through this? How to calculate current flowing through a voltage source? Because directly voltage is known, but current flowing through voltage source will be decided by the network connected. So directly we cannot apply kind of Ohm's law here. We have to apply KCL here. Now leaving current through this is 1 and 4 volts, 2 ohms. So leaving current through this is going to be 2 amperes. And leaving current through this is going to be how much? 4 volts. With respect to this is 4 volts. With respect to this is also 4 volts. So this is going to be 0 amperes. Right? Now how much is the current flowing through this? IS 1 plus 2, 3 amperes is going to be source current. How much is the source voltage? 4 volts. How much is the Thevenin's equivalent or Norton's equivalent resistance? Is going to be 4 by 3, 1.333 ohm. Okay. Now let us see. In the network figure, maximum power is delivered to RL if its value is. Let me make it big. Here RL is there. This is 20 ohm. This is 0.5 I1, and current flowing through this is I1. This is 50 volt. This is 40 ohms. Now, the maximum power delivered to RL if that its value is. What does it mean? Like they can ask Thevenin's voltage, Thevenin's resistance. But did they ask both? No, they asked only resistance. The moment they ask only resistance, what can be done? Independent sources can be killed. And only dependent source will be there. Kind of external excitation in the last problem, whatever we have done. So, Let me kill independent source. Dependent source, we should have dependent source. And across RL has to be removed. Now this circuit will become, this is 0.5 I1 and this is 20 ohm and this is 40 ohm and current flowing through this is I1. And now we have to externally excite it. Now one thing, can I combine this and this as kind of resistances are connected in parallel? See here, 40 ohm, 20 ohm, are they connected in parallel or not? Yes. The moment you remove this, you short this, 40 and 20 will be connected in parallel. Now can I combine that? No. Why? Because controlling variable is there. If controlling variable disappears, you will not be able to analyze controlled source or dependent source. Okay. So these two should not be combined. But can I combine these two into equivalent voltage source? Yes, you can do that. Because controlling variable means you are giving life to controlling variable. Now, coming to here, we are supposed to connect one voltage source or current source. Which one is better to connect? Which one is better to connect? If I connect voltage source here, for example, of 40 volts. 40 volts. If I connect 40 volts, how much is this current? Is going to be 1 ampere. 40 by 40. Meaning that how much is this current? 0.5 ampere directly. Meaning that dependency you are able to cover up. Okay. Now you have to find current flowing through this. Source current forward. So how much is going to be source current? Source current is going to be I1. Is going to be 1 plus this. 40 divided by 20 is going to be 2 plus this minus 0.5. Right? From here means current flowing through the source is nothing but this current plus this current plus this current minus 0.5 because 0.5 amperes is entering into the node. So this is going to be 2.5 amperes current flowing through the source. Meaning that how much will be the Thevenin's equivalent or load resistance such that load will get maximum power transformed is going to be 40 by 2.5 is going to be 40 by 2.5, 40 by 2.5. I think 16. Fine. Now let us consider this problem. In the circuit shown in the figure such that power transfer to RL is maximum. Power transfer to RL should be maximum. It is funny question. Because all are independent sources. The moment all are independent sources, current source open, voltage source short, and across RL you have to, from RL you have to look into the system, 10-10, parallel 5, 5-10, series, 15 ohms. Okay. Let us think of this problem. This problem is kind of magnetically coupled kind of, but it's a transformer, directly ideal transformer they mentioned. If the secondary winding of the ideal transformer shown in the circuit has 40 turns, see here it is having 40 turns. And how many turns we should keep here in the primary such that maximum power should be transformed to 2 ohms resistance. When maximum power will be transformed to 2 ohm resistance, kind of if I transform 2 ohms from here to here, it should become 8 ohms. Then you are going to get source voltage 8 ohm, 8 ohm it should be. This 2 ohm, once you reflect from here to here, it should be 8 ohm. 8 ohm, meaning that it should be 2:1. Because what is reflected, reflector resistance is going to be, for example, if I think of this as RL, RL dash is going to be 2 into N1 by N2 square, 2 into 2 by 1 square is going to be 8. Right? So if I have 40 turns here, compulsorily I should have 80 turns here. That's it. Let us see one more problem. See here, this is also funny question again. Source voltage value they have given. Source voltage value they have given has an internal impedance of 4 pi J3 ohm. If a purely resistive load connected to the source has to extract maximum power out of the source, the value of ohm should be. They got source voltage like this This is 3 plus J4. And here they want to connect purely resistance only. Okay. And this is variable. This is load resistance. And this is 3 plus J4 ohm. Meaning that it's going to be 5 at an angle 53.13 degrees. 5 ohms. So RL should be 5 ohms. Okay. Thank you.